Hello and welcome to my channel again. So here I am Suraj again with a video on the Fourier series. As in my previous video I have discussed about the Fourier series and all that things. But in the Fourier series the integral is also very important. So now we are going to evaluate the four very important integrals in the Fourier series. So in this video we are going to discuss only one of the particular integral in the Fourier series, which is very important. So now let's start our video on solving this particular integral in a more intuitive explanations and easy explanations. So for this I'm assuming that you know the basic integrations, not very advanced integrations, basic integrations. So now let's start our video on the Fourier series on solving this particular integration, which is very important out of all four. So now what I can make is that what is the time period of a cos function? So in the class 11th you have studied in the trigonometry functions topic that both cos and sine repeats its value after every 2 pi. It means we can say that its time period is 2 pi. Both cos and sine have the time period of 2 pi. So what we can do is that we just substitute the integration limits from 0 to 2 pi of the cos nx into cos mx dx. Cos mx and dx is equals to the pi, because L is 2 pi, so 2 pi upon 2 is pi. So this is the integral, yani it means we have to prove that the integral of cos nx of dot product of cos mx from 0 to 2 pi is equals to the pi. So let's start our integral. And remember, it is only possible if m is equals to n, but m is equals to n is greater than 0. If it's becomes 0, there is another method of solving the integral which I'm going to do in the next video. Okay, so we can evaluate this by very easy. So if m is equals to n, it is very clear that we can write it as cos square nx. Yeah, we can write it cos square nx, and it is applicable for the all values of n. N is can be any value, 1 2 3 4 5 6 7 8 9, whatever. So for this situation, for simplicity, we are substituting the value of n as 1. If we substitute the value of n as 1, our integrals become like this, that the integral from 0 to 2 pi cos square x into dx. Now it is very easy to evaluate this integral. So to evaluate this integral, remember a trigonometry identity, because the trigonometric identity is very useful in solving these types of integrals. So what's the trigonometric identity is that the cos square x can be written as, it is similar as 1 plus cos 2x divided by 2. So this is a very important trigonometric identity. It means we can substitute the value of cos square x as 1 plus cos 2x by 2. So substituting the value here of cos square x as, substituting the value of cos square x as the integral from 0 to 2 pi, from integral of 0 to 2 pi 1 plus cos 2x and divided by the 2 into the dx. So this is our integral. Now using the basics of integration, which is key, whenever we have to do the integration like this, we just separate out our integrals. So we can separate it out by the thing. First of all, we have to put out 1 by 2 from outside, and after separation we get is 0 to 2 pi dx and plus 1 by half integral from 0 to 2 pi cos 2x dx. So now this integral becomes simple. So here it becomes, the integral of dx become x, it means 1 by half x and 0 to 2 pi. So evaluate this a second type of integral. What we have to do is that we have to use a method of substitution in integration. What method? Substitution. So what substituting is that I take sine 2x as t, and differentiating on both sides with respect to x will give 2 cos 2x is equals to the dt divided by the dx, and putting dx on this side and 2 in this side, we can clearly get this that cos 2x dx is what equals to the dt by 2. It means substituting this particular value of the cos 2x in this integral will become 1 by 2 integral from 0 to 2 pi dt divided by 2. Now again here, if I put the value of x here 2 pi, it will become 2 pi divided by 2 and minus 0 by 2 and plus putting 2 outward of this particular integration, it will become 1 by 4, and the integral of dt is what equals to the t. Integrals of dt is what equals to the t, so it is 0 to 2 pi. Okay, next what we have to do, so first of all our this integrals become, if we cut out 2 and 2, it will become here pi. Okay, so it will become here pi minus here 0.2 is 0, so we do not write this, plus here 1 by 4, and putting the value of t as sine 2x, because we have substituted the value of t as sine 2x, so sine 2x from 0 to 2 pi. So after this what we can do this is that pi plus 1 by 4, 1 by 4. First of all, putting the value of sine as x as 2 pi, it will become here into sine, here becomes sine, sorry, here it will become sine 4 pi. Okay, it will become sine 4 pi, and here minus sine 0, because we put the value of here 0 in this particular expression, it will become sine 0, and sine 0 is equals to the 0. So what we see that sine 4 pi is also 0. It means this whole particular, this whole things become 0, and if this whole things become 0, what we left is with pi. It means pi. Hence this is the answer of this particular question, pi. So this is the first integral in the Fourier series. So in the next video I'm going to discuss about the all of the three other integrals in the Fourier series. So thank you for watching my video.